Hello friends, this is Durga from ITversity. As part of Hadoop MapReduce application development, at this time we are talking about distributed cache, implementation of it to perform join, and we have defined the problem statement of joining New York Stock Exchange end of day data with the company dataset and get the company names, stock and industry. And for that we have developed parsers, one for company metadata, which have the company name, industry, sector and some other company macro level information, and other one is New York Stock Exchange data. And also we have created a package stock company join .distcache, and in that we already developed a mapper. Now let us develop a driver which is which actually runs this MapReduce application, and we will first run it as a map only job just to make sure that we are getting data as expected out of the mapper, and then if required we will develop the reducer. Okay, to develop the driver you can pick any of the previous drivers, either from top 3 stocks by volume per day driver, or we have another one for average stock volume per month also, and we will copy one of the drivers from here and then paste it here, and then double click this driver file. And let's review the code. First rename the class name. Our class name is not top 3 stocks by volume per day driver for distributed cache demonstration. It is stock company join dist cache driver. Okay, and hit continue. So we are using the existing driver class as templates, and I'm not going into details about everything. I just want to recollect about this code. So when we run our MapReduce application was developed earlier to get average stock volume per month and also top 3 stocks by volume, we are passing 3 parameters for our Hadoop jar command while running this MapReduce applications. The first one is the base directory for the input path, and the second one is like this, wherein you can pass a pattern to filter out the directories which you are not interested in, and the third parameter is the output path. Okay, and this has the logic of dealing with the file system APIs of Hadoop and filter out the directories which you are not interested in and only consider the ones which we are interested in while running the job. And then input format class is combined text input format, because our input data has too many small files issue. So to address that we will use combined text input format. Let's recollect dataset again so that there is no confusion. So this is our dataset. This will be our base directory for processing the data, which contains 6 directories, one for each year: 2009, 10, 11, 12, 13 and 14. And if you open any of the directories and try to list the files in that, you can see that there is one file for each day, and it is only on average 100 bytes. And if you directly process data like by using default input formats like text input format, then it will invoke too many mappers unnecessarily to process this data, and which is not good. So for that reason we are using combined text input format. I have explained earlier also. And then our driver file is our mapper class is stock company join dist cache mapper, and we don't want all these things, so all these three things. We are running, initially we will be running a map only job only. So for that we don't need the comparators like grouping and sorting comparator, and also we don't need to use custom partitioners. And the number of reduced tasks should be set to 0 because the job will be run as a map only job. And reducer class is not required. And output key class should match the mapper output in this case, because we are not using reducer. Or actually we can even remove these two things also, because whatever is coming out of mapper is already defined, it should be defined accurately. And if you go to the join distcast mapper, the output key type is text pair and the output value type is text, so it should match here. So it should be text pair, not long pair primitive or long pair. Okay, so that's it. Your driver is ready. Now let's run this program. For that, you have to first build the jar file, and we will run it on our Hortonworks VM. Right click on this, run as, Maven install. Okay, let us copy the path from here. You should only pick up where it says installing, and you should pick up the correct jar file, because if it is a packaged project which have multiple modules, you might see multiple jar files like this, and you have to pick up the latest one. And to pick up the latest one, you can look at the pom.xml, and you should pick up the correct one. To pick up the correct one which you are interested in, you should use this artifact ID and version ID. And if you merge those things and append with .jar, which is used as part of packaging, you will get the jar file name. So I already copied it. Let me do the SCP. I am copying it to my home directory. And also, if you look at the code, we have not done anything with respect to distributed cache as part of the driver. In Mapper, yes, we have done. We have developed this setup. We have developed this initialize method and invoked for setup. And in initialize, we are reading this file directly without any absolute path. We are just passing the file name. Okay. So we have to pass this file from when we run Hadoop jar command, which we'll see in a moment. But if you look at the code of the driver, we have not done any changes with respect to distributed cache, because we will be passing the CSV file for company dataset using minus files control argument as part of Hadoop jar command. If you want to make changes to the code in the driver, instead of passing using minus files, then you should use these methods, add cache file and add cache files as part of the code. So if you add these lines as part of your code, then you don't need to pass minus files while running the command. So they are mutually exclusive. You can either pass using minus files or you can hard code as part of your program. But the best practice is to pass using minus files, because it will give you more control. Okay, so now we have copied. Now we have to do SSH. And let me run the Hadoop jar command, and Hadoop jar file name, which we just copied, and then nyc.stock company join.distcache, which is the package name from here, and then stock company join distcast driver minus files. And let me show you one thing before running the command. So I have this company list underscore no header locally. So when you actually use minus files, you can either pass files local to your client node if you are using a multi-node cluster, or you can actually pass file from HDFS by using HDFS protocol, and even from the other supported protocols like S3, WSB. They are cloud-based protocols. S3 is from Amazon and WSB is from Microsoft Azure. So you can use those cloud-based locations also, which are supported by Hadoop, and you can pass the files not only from the local file system but also from cloud-based file system as well as HDFS itself. Okay, in this case we'll be using local files, which is this company list no header .csv, and as part of that we can either pass absolute path or relative path. Absolute path for this file company list no header .csv is this one in local file system. Sorry, ls-ltr. So let me do the pwd. So we are in /root, which is the home directory for root user, and under that we have this company list no header .csv. Okay, we can actually make a directory for company list and move company list underscore no header .csv to company list, and then for absolute path for this file it will be this one, ls-ltr root company list. So this is the absolute path for this file, and the relative path is from the current directory to that location, which is company list. So this is the relative path. So we can either use the absolute path like this, or we can use relative path like this. Why I am emphasizing on this is a lot of people who are not familiar with Linux and who don't understand the rationale behind this absolute path and relative path, the difference and rationale between those things. They tend to make a lot of mistakes here and they're stuck for a long time. That's why I'm emphasizing a lot on this. Anyway, now let's go to the Hadoop jar command. And here let us give the relative path, which is company list / company list underscore no header .csv, and this is the HDFS path /user /root /raw underscore data, the base directory for our New York Stock Exchange data. And then the second parameter, so that is the first parameter, which is the directory path, and the second parameter is the pattern to filter only the years which we are interested in, which is 2012 and 2013 in this case. I have explained earlier in detail when I talk about filtering effectively using file system APIs. And then third one is output path, which should be a unique non-existing directory. So I am renaming the directory name to distcast03 and hit enter, because I have already ran earlier, and there are directories already with names distcast 0001 and 02. So I am just giving a unique name and hit enter. So there will be some issues in the code, both in mapper as well as the driver. We need to fix those things. Let us review the data first. And also from the previous program to this program, as part of the mapper, I have added one additional line. This company not equal to null, just to handle null pointer exception. If you look at my previous video, you will not see this line, but now I have added that to avoid the null pointer exception, and you can see that as part of the output, even though there are 1.509 million records for input, output is only 1.279 million records, because there are some stocks which are in New York Stock Exchange data but not in company list. So whenever we try to look up as part of our program, sometimes you will not get a corresponding company parser object which have all the company details, if the hash map does not have the key associated with it. So if the hash map is built as part of our mapper function, as part of our initialized function, we are building hash map for the company data set. So if there are companies which are in New York Stock Exchange data but not in company data set, then definitely this will raise a null value, and you have to handle that gracefully. For that reason I have added this. So if you don't add this, you will get the null pointer exception. So make sure that you have this. And even after adding that, let's review the data now. So Hadoop fs-ls user root, our output path is dist cache 03, hit enter. You can see the file here. I have only one file. It's a map only job. That's why it is the file is renamed as file is named as part minus m. M stands for mapper. If it is a map reduced job, then the typical file naming convention will be part minus r minus the number. And here let us do the Hadoop fs minus get. Copy this path and then rename it as dist cache 03.csv. So the file is copied from HDFS into local file system, and you can see this dist cache 03.csv here, which is copied to the local file system, and we are viewing the data in that. And if you see, the first two fields are stock ticker and the date, because we are emitting those things as part of the map function. We are emitting both map output key in the context.write and map output value. If you don't want to see these two things, what you have to do is you have to create a null writable object here, as we have done earlier, and only emit the output value to the HDFS. After first two fields, which are part of the key, the next 7 fields are comma separated till here, and you can see the stock ticker, trade date, and then four prices, and then volume, and then you can see 3 additional columns. But if you see, there is an issue with this data, with this output. So there is a bug in the code. So the last 3 fields are repeating for all the records. For A, the company name is not Zweig Total Return Fund. There is something wrong. Even for AA, it's the same thing. So we need to fix that issue. I already know the fix. So go to the mapper. Here the issue is we are invoking the pass function. So as part of the pass function, if you go to the company parser and pass code, okay, we are not building a new company parser object every time. We are actually replacing the existing company parser object, and then we are actually setting that object which is being replaced every time and into the hash map. For that reason, what will happen is the object byte address, the object is same, yeah, in all the values of all the keys in the hash map. So when you loop through all the companies, and when you actually add the last one, as all the values are pointing to the same object in our hash map, when you the last stock name is added, means the only the last stock details or last company details are preserved in all the objects. So it override, or as it is, as all the keys in the hash map are pointing to the same object reference, we are getting the same stock name, same sector, and same industry for all the stocks as part of the output for our job. For that reason, instead of invoking parse method, what we have to do is we have to create a constructor, and we should use the constructor so that we build a new object every time we pass we pass the line in our company data set. So let's do that. So I'm creating a constructor public. Constructor name will be company parser, and I want to pass the string record as a object to the constructor. So it's not a default constructor, and then I want to invoke this pass function. Okay, and as part of the company join distributed cache, because there is no default parser, default constructor, we created the constructor with the argument, so it started showing error here. So we should do null here, and then instead of invoking pass function with the line, we have to invoke with the constructor. So new company parser of line. Okay, and now we are actually building a new object every time. So it will each key will have a different object reference, and which corresponds to its own company related data. So the key and values will match now. And also it seems we have to change elsewhere also. Let's click on this. Here also it is calling the constructor. So what we have to do is, yeah, we just say null just to initialize it, and then we are assigning a new object every time to the company. So the get will get the company parser object, and we are assigning it to it. So we don't need to initialize with a constructor here. That being said, now we made the necessary changes to fix the bug in the code. So now it is compiled. Now we have to recopy the jar file. Now we have to do the SSH. So the output seems to be garbled a little bit, but that's fine. I don't care much about it at this time. And now run the Hadoop jar command with a new directory distcache04 and hit enter. It will just take a moment, and then we will review the result. Okay, so the map input records are 1.5 million and map output records are 1.279 million. So we are actually discarding almost 200k records, which should not be the case in real time scenario. We should try to fix the issue by getting all the data for company list, or we should handle the situation more gracefully, but I don't want to get into that at this time. Now let us review the output. Again, I am getting the file which is created as part of the last run. The path will be this one, distcache04, and the file is created. Now if you see, it is 15 MB, earlier it is 13 MB, so there is a change in the data. So from the file system attributes itself, I can tell that there is change in the data. Now we will open the file and make sure that the issue is fixed. And you can see that A stands for Resilient Technologies, and it belongs to electrical products industry or sector, and capital goods industry. So let me see which field is what. Company parcel. So yeah, so sector is electrical products and industry is capital goods. Similarly, AA stands for Alcoa Inc. AAN stands for Aaron. AAP stands for Advanced Auto Parts. Let's validate for some known companies like AAPL. It's not there here. BAC, yeah, BAC stands for Bank of America Corporation. It belongs to major banks sector and finance industry, which is correct. So like that we can validate few records, and then if this is the desired output for your business, you can build the application and submit for deployment in QA and get it tested from the QA to complete the life cycle of the implementation. Anyway, that being said, that's it for this video. We have developed the mapper as part of the last video, and we have developed the driver, and we have invoked the mapper, and we have validated the results. It looks as expected, and also you might be curious why we are not actually passing absolute path when we invoke this initialize method. So in the initialize method, we have hard coded the file name as company list underscore no header.csv, but we didn't specify any path to this. As I have explained earlier also, as part of the theory, what will happen is for each run you have this, so there is a local directory, there will be a local directory on each of the node in the cluster. Wherever the job has run, wherever the map tasks which is using the distributed cache has run, you have to go to those local directories, which is Hadoop yarn local in this case. Again, the parameter you can get it from the list I have given in this presentation. The parameter name is yarn node manager local directories, and whatever is there in that parameter, that should be the location which you should look for. And in that there is a user cache, and there will be a directory for each of the OS user used to run the jobs. So our last job is run using the root user, so you should go to the root directory, and in that there is a file cache, and now you can see that there is a unique directory which is using a unique number. And if you see, we have run this the distributed cache program twice, one with the old code and one with the new code. For each run it has created a new directory, and if you go to either of the directories, so I am actually doing ls-ltr on 671 and 672 directories, and you can see that both have this company list underscore no header.csv, which we are passed using Hadoop jar command. So as the paths are changing on regular basis, you cannot use the absolute path here. You just have to specify the file name, and as long as you pass a correct file using correct path using minus files control argument as part of Hadoop jar command, framework will take care of copying this to that unique directory location for each run, and it will successfully resolve the file and get the file to build the in-memory structures like we have done here. So the logic which this is the logic which is to build the which is used to build the in-memory structure of this company list data. Okay, without doing this, your Hadoop programs cannot read this data through. So in short, you have to implement the setup method, and as part of that setup method, you have to either have the logic to convert your data in the file into a memory structure, or you can modularize like this. In this case, initialize is the method which is used, but I am invoking that from the setup method. Okay, that's how it runs. As of now, that's it. In the next video, we will try to see how we can use the reducer just to complete the end-to-end life cycle, and we will try to we will not do any aggregation, but we will try to create files in more so instead of having one file, we will try to have multiple files so that data is distributed and can be used for effective filtering in future. Okay, that being said, I hope you are enjoying the content in this channel, especially this playlist and this video. If you like it, please click on the like button. If you want to provide feedback or ask any technical questions, please use the comment section of the video. And if you have not subscribed to this channel yet, please do so. You will got to see a lot more content like this over time. Thank you. Bye.